Bom, tivemos um grande problema que eu cliquei em começar a live, minha internet caiu. Agora voltou. Então já voltou faz um tempinho. Eu jantei, que eu estava jogando, né, enquanto o tempo estava fora. Isso inclusive vai ser um... Eu vou elogiar Xbox Game Pass, que eu estava sem internet, mesmo assim consegui jogar meu Claro Obscur. Então mesmo assim consegui jogar meu joguinho. Muito bom, por sinal. Acabei de lembrar de uma coisa, senão eu vou esquecer. Vamos ver do Alan. Alan Zoca, Claro Obscur, mas a gente não pode ver para não pegar spoiler, então a gente vai... Ó, por favor. Goblo e as flores.
Gente, vambora! Clair Obscure Expedition 33.
Ah, tá. Tô com 4 horas de jogo, então faz sentido.
Bom, gente, vambora. Continua aqui, número 2.
Águas flutuantes.
Oh, não, calma lá. Dá pra fugir da luta?
Not leaving you behind.
Nossa, eu não acredito que eu perdi o número das águas flutuantes.
Eu esqueci de botar minha skill. Gente, por que essa porra não toma dano, mano? Ele tá com a barreira supersônica.
Spoiler aqui. Beleza, Burgeon. Ah, beleza. O Goblo.
Posso passar do 1 hoje. Só amanhã.
Ah, ele joga a pedra, beleza. Eu tô longe.
Still too far.
Beleza, não é esse então. É o Conhecendo Esk. Só que...
Gente, vambora! Continuando. Ah, boss final, não tô acreditando nisso.
esse é o boss do... Não. Esse é o primeiro
velho. O Marcos vai pros 14.
Sacatape.
That's a lot of dead Nevrons.
É, isso mesmo.
Who did?
A storm is coming.
Rune, watch out!
Tá bom, tá bom, tá bom. Sim, né? Não foi só no fim.
I still can't believe they exist. I mean, what other fairy tales are real?
This is ultimately a war of information. There's still too much we don't understand.
Frente à senha?
Get out of my way.
Very gestural-ish.
Esquinesto tesokima villaggio. Suniso.
For everything.
Pose. Respecto.
Você vai falhar muito, Alan.
Tanca mais. Não tem como eu morrer, tá? Ela tá upada?
Não, não tá upada.
Meu Deus, ela nem tomou dano! Ah, pô, você não tomou 1.000 no teu cu aí, velho, pelo amor de Deus.
Tá, ele vai voltar pra... Ele vai pro acampamento.
Obsessed with your arm. Your apprentices would be extremely proud knowing a Gestural loves their work.
Yeah, they'd be insanely
You gave the 8-11.
until
Cadê?
Ah, eu também. Fiquei procurando a mail.
Mael! Mael! Merda! De onde estás? Mano, cadê a Mael?
É, né, putão. Vai, Alan, esquerda, esquerda, esquerda. Aí, boa. Aí. Alan,
Mael!
agora.
Achei.
maybe you should stay.
What?
It's safer in the village.
Missed the chance to meet SK? No way.
Caralho, eu peguei dela. Agora que eu vi.
I'm okay.
Se conversar em 3 pontinhos é foda, né?
Nossa, tem essa opção de conferir com os outros. Eu achei que era só, tipo, me deixar livre. Meu Deus, eu sou muito burro. Ah, vamos ver.
You okay? You've been quiet since we left the village.
Yeah, sorry. Just bad memories.
Wanna talk about it?
No.
No.
Putai.
I'm glad you're here.
I would never abandon a member of Aquafarm 3.
Aquafarm 3.
Aquafarm 3.
Só pra avisar, eu
So
sou
long
viúvo,
ago.
tá? Solteirão.
Sophie, we're
Yes,
inseparable on that
yes.
project.
Yeah, we were.
That was a good project. It fed so many neighborhoods at once. Kind of nostalgic thinking back. We really thought we were making a difference.
Hey, we're still making a difference.
Yes. Of course.
Yeah.
Tá vendo aquele número ali? 33? É o número de vezes que eu pensei em você hoje, bebê.
Ok.
Que isso, Gustave?
Dormir? Não, escreve no diálogo. Diálogo.
Vai ter...
ESKA.
Boa.
The gestuals. And
Vou dar um bagulho pra vocês aqui, tá? Eu estava nessa cutscene quando meu cachorro quente chegou. Então eu tive que sair correndo. E, cara, por favor, nunca façam jogos que não seja possível pausar em cutscene. Se não deixar pausar, bota um HUD pra gente rever essa cutscene depois. Porque isso é péssimo. Cara, eu odeio isso. Eu odeio não poder pausar em cutscenes. Ainda mais se a cutscene foi, tipo, gigante. Então é isso. Estejam cientes.
SK. The tales are true.
Eu perdi a hora que ela acorda. Aí ela entra, a mulher vem com ela. O cara vem encher o saco, daí ela acorda. Nossa, a Amelia com esse cabelo tá muito estranho.
White hair. Who are you?
Brasil deve ter um 2. Eu não sei se foi semana passada ou se 2 semanas atrás. E jogão! Mas eu não sei se
Alicia.
esse
I told you to stay home.
vai ficar pior
It's
que
not
ele.
good for you to see this. Yes, I understand.
Ela mesma?
It's
Então,
her
eu acho que é
fault,
ela
and she
mesma.
doesn't
Ou é
even
uma
know it.
dela.
But you can't be here.
talking
Esse é o
about?
Gustav?
What's my fault? What is this?
You should never have come. You're only going to make things worse for everyone. Now take your friends and go home. Let them spend their final year
Dá pra ver a mão, não dá?
in peace.
Ele não mostra a
This
outra mão.
is your only warning.
I can't wait to see.
Man?
Hey.
Hey. Hey, hey, hey.
Mano,
Baguete.
Hey.
Sam,
ela com essa esquema.
I saw him. The white-haired man and this woman.
Where?
Did
What are you
see?
talking about?
Mael, breathe. Slow down. What did you see? Think carefully. Every detail could be important.
É, o cabelo é igual, mas só o cabelo já.
He said we need to go home and that it's my fault. And that I'm gonna make things worse for everyone. You were all frozen. I couldn't. It was like a waking
It's
nightmare.
okay. It's okay.
What
It's
else?
over.
You said there was a woman.
Lune, maybe later.
She had a mask and
I know this is hard, but I need you to focus, okay? While the details are fresh.
Lune, ask her tomorrow.
Pô, o Gustavo também é chato. Tudo bem que eu entendo que a mulher foi
Hey,
chata,
hey.
mas o Gustavo é chato.
Breathe. Listen to me. You're safe. Do you understand? Okay? It's over.
Como que é? Furdouço. Will come? Para aqueles que ainda estão por vir. Sei lá, não esqueci. Beleza. Vai dar isso. Isso, é exatamente essa parte que eu estou. Clara obscuro, clara obscuro, clara obscuro. Beleza, vamos lá. Ah, cara, é 11 horas da noite, mano. Eu abri essa stream, sei lá, 7h30. Eu fiquei sem internet até as 10, pelo amor de Deus. Pelo amor de Deus, cara. Que agonia. Tá, vamos lá. Tô bem ansioso pra essa outra parte. Eu não tava muito ansioso ontem, porque eu estava morrendo de sono. Mas agora tô bem ansioso. Cara, meu microfone é meio zoado, porque quando eu faço isso vocês escutam uns trondos gigantescos, mas eu preciso fazer isso. Nossa, mano, esse suporte que eu comprei é péssimo. Code. Hello World. Bom, vamos voltar, vai.
The scroll, we'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with
Empty.
and the name of the script should be main as well with a non-capital M. This creates a script
Node.
with two functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen immediately. I'll get rid of the other function for now. You can zoom in by holding down Control while scrolling. Now right now the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside of the parentheses we'll put our message in quotation marks, hello world. We can then run the game by pressing this button here or hitting
Caralho, não tô no Mac. Cara, eu nem lembro qual que era o papo que a gente tava antes, então... Só já era.
F5. It's going to ask us which scene we are going to run. We'll hit select current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints and is also where we check for errors. Now to stop our game from running, we press the stop button here or press F8. Syntax. Now, this might have worked for you and it might not. That's because there are a few things to be aware of when writing GDScript. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GDScript, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GDScript where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GDScript is case sensitive. So if I write print with a capital P, I will also get an error. So just a couple of things to look out for there. Now printing to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window instead. To do that, we'll need to modify a node through script. Modifying nodes 1.0. First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label. I'll center it and override the font size. Now, to edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text.
Como assim? Por que o dele tá bonito?
If we need to this a room, I'll zoom in, center it on the screen. Make some more room.
Nossa, isso é legal. Meu Deus.
Let's add a default text. This is a label. I'll center it and override the font size. Now to edit this,
Tá. Okay.
the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function. Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when we play, our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there's a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, write .modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there's a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to...
Nossa, calma aí. Beleza. fonte, acho que é fontes? Não, colors, também não. Vou ter que ver, visibility. Composite, visibility, modulate. Ah, ele mostra, modulate, color, igual a color, RGB ou HSB.
Green. So again, we'll click and drag to create a reference to the label, write dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input to make our game respond to our actions. Input. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go project, project settings, input map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or so on. In our case, we wanted to change a color. I'll just go ahead and call it my action so we can use it later for other things. Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm gonna press the spacebar and hit OK. And now our spacebar is bound to my action. Then in our script, we need to create an input function. We'll write func for function underscore input, and let's hit enter to autocomplete. Now just like ready, this is one of the built-in functions of Godot. But instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check if the event that triggered the input was our action being pressed. So we'll write if event.isActionPressed, and as you can see, our action shows up here, my action. Then we'll put in a colon.
Na minha cabeça isso é muito mais complicado. Eu preciso fazer um if para todo evento, então? Nossa, calma. Eu vou ter que... Não, vambora. Nossa, gente. If event.is action pressed. Action pressed. My action. Label.modulate. Subcolor.red.
And if we pressed my action, well then we'll change the color. So we'll drag in the label, write dot modulate, and set it equal to color dot red. And we can just as easily check if the action was released. We'll go if event dot is action released this time, my action. Well then we'll take the exact same line and change it back to green. So now when we play and I press the spacebar,
if event.is action released, my action. Oh, isso é legal. Isto é legal.
it turns red, and when I release it, it turns back to green. That's right, we made a party. A disco party.
Maravilhoso. Ai. Como é que eu achei um negócio legal aqui? Tá falando sobre coçar minha cabeça na primeira live.
Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before...
Cara, eu apaguei tudo? Não é coisa da hora pra nada. Nossa, eu estou começando a ficar com sono de novo. Cara, eu não posso comer que eu fico com sono.
Printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20 to our health. And subtract, health minus equals. To multiply, we do times equals. And to divide, we do slash equals. So if we run this now, it will do all of these calculations from top to bottom and then print out the result, which turns out to be 120. Let's look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier. So in the input function, we'll check if the action was pressed, and then we'll subtract from our health. And we can print the result.
Tá, isso é legal.
So now every time I press...
Isto é legal. Find if... Não. Calma.
The spacebar was pressed.
Ah, input event. Input event. Qual que é o problema aqui? If event point is pressed, my action não sei porque eu não vi essa porra logo. Health menos igual 20.
And then we'll subtract from our health. And we can print the result. So now every time I press the spacebar bound to my action, we can see that I reduce the health. Really cool. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements, or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0. And we'll print that we died. And now when our health gets to 0, it prints you died. Now here we're using less than and equal to compare our health to the value 0. But there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on. We can also add more conditions to one if statement. We use the AND keyword to add another condition where both need to be met, and the OR keyword to add a condition where only one of them needs to be met. Now, one really useful thing about if statements is that we can not only define what happens when the condition is true, we can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached 0 yet. So if our health is less than or equal to 0, we died. Else, we print you are healthy. And even cooler, we can chain together if statements using else if or elif for short. So we check if our health reaches 0, and if not, else if elif our health goes below 50, well then we'll print that we are injured. And if neither of these two are true, we'll go to else and say that we are healthy. And if we play, we can see that at 80 we are healthy, at 60 we are still healthy, then we are injured, and at 0 we die. Very cool. Note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Plato. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what and the why of our code. Adding a comment is simple and can be done above or after a line. So if we have some code, we can make a comment above the line, and this is a comment about the code that follows, or we could make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and is something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we're working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool for true and false, integer, or int for whole numbers, float for numbers with decimals, and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, and we have some text, which is a string, well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to, say, convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, and we have some text, which is a string, well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the parentheses. And if we print this, it works fine. We can do a similar thing to, say, convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. and it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically type a variable, we simply add the type when declaring it. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing := and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to -9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Functions. Functions are the bread and butter of programming. They allow you to bundle up your code in small reusable packages. So far, we've been using some of Godot's built-in functions like ready and input. Notice how these are prefixed with an underscore. This is to show that they are not activated or called by us, but by the engine itself. But we can actually make our own functions and use them to do really cool things. Common functions to making games are things like jump, die, shoot, and respawn. And making a function is actually really easy. Let's make a function for jumping. So we'll write func. Then the name of our function, open and close parentheses, and a colon. Then in here we'll put all of our code for jumping. So we could add an upwards force, play a funny sound, and a jump animation. For now we'll just print jump. But nothing is currently triggering or calling our function. Let's call it whenever we press the action we made earlier. So func_input event, and if our action was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump. And at this point, I encourage you to add the sound effect yourself. Boing, boing, boing. A lot of fun to be had here. Now this already makes our code more readable and reusable. But right now, our function is just a simple command. We call it and it does some things. However, we can actually use functions for much more than this. They can have inputs and outputs. Let me explain. I like to think of functions as machines. Take for example this coffee maker. Just like the name implies, it performs a function to make coffee. To do this, however, it needs some input. Some water, a filter, and some ground coffee. With this, it performs its function and then spills out an output. Delicious coffee. In code, we call the input we give our function parameters, and the output is called returns. So let's make a function that adds together two numbers, func add, and then inside of our parentheses, we add the parameters. So number 1 we'll call num1, and the second number we'll call num2, Then inside our function, we can add these together and store them in a result variable. So we'll set that equal to num1 plus num2. And for now, let's just print the result. Then in ready, let's try calling this function. So we'll call add. We'll give it the first number, 3. And the second one, let's do 8. And let's actually call it again. So let's do a harder one. Let's add 245 with 111. And indeed, it prints 3 plus 8, which is 11, and 356, which is the result of our second calculation. So here we've created a function with 2 parameters, the numbers we want to add together. But the function actually doesn't return the result. It just prints it. This means that we can't actually access the result where we are calling the function, up here in ready. To return the result, we replace print with return. So we'll do return result. And now up here, we can store the result in a variable, set it equal to add, and we'll add together 3 and 5. And we can print that, and the result is 8. And because we have access to it up here, we can do more things, like add more numbers to it. So we can set result equal to add, and pass in the result from before, and add 10, and then print it. And there you go, we now get 18, because 3 plus 5 plus 10 is 18. Really cool. And just like when declaring variables, we can also statically type parameters and return types to make it clear that the function is made to work with numbers. So after num1, we'll specify that this is an integer. We'll do the same thing with num2. And here we can set the return type using an arrow, and this is also an integer. So now this function will only work with numbers. 3, 4, 6, 8, 2, 1, 1.5. Random numbers. Getting random numbers is very easy. The function randf gives a random number between 0 and 1. It's great for assigning probabilities to your code. Say we are deciding what loot to give the player and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf. Then we could check if the roll is less than or equal to 0.8, which means there's an 80% chance that we print you found a common item. And if not, well, then there's a 20% chance that you found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually there's a 20% chance, so at some point we'll eventually find a rare item. That was crazy. We can also use randf range and randi range to get a random float or integer between a minimum and maximum value. Say to assign a random height to a character. So var character height equals randi range for a random integer between 140 and let's do 210. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll a character, and apparently I am a giant. Basketball, here I come. Documentation. GDScript is actually pretty well documented. And one of the really cool things about it is that the documentation is linked with the editor. If we hold down Control and click on something we would like to know more about, such as the randi range function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So we'll create a normal variable and set it equal to open and close square brackets. This creates an empty array. We can then add elements inside the square brackets. I'll add a potion string, the number 3, and the number 6. Notice how, unlike many other languages, GDScript has no problem mixing data types within an array. But if you want to constrain an array to a specific type, we can of course statically type it. So here we simply add the type. This is an array, and the elements inside it are going to be strings. So that's the syntax for that. And now we get an error because 3 is not a string, so we'll replace this with feather. And 6 is also not a string, we'll replace that with stolen heart. Now the way that we access elements in an array is by using an index. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element, potion, has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out potion. Pretty cool. We can just as easily change elements. This changes the second element to smelly sock and the third element to staff. And arrays also have functions for finding, removing, or adding new elements. So to remove at an index, we write remove add, and then the index 1, this removes the smelly sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out. Loops, loops, loops. Loops allow us to repeat code a number of times with small variations. They are perfect for iterating through all the elements in an array. If, for example, we wanted to print out all the items in our array here, we can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at, we'll just name that item. In the array, so in items, we will print out the current item we're looking at. So print item. And as you can see, it prints potion, feather, and stolen harp. This is cool because we can have any number of items in our array. The code will work just fine. We can also add more functionality, say to only print items that are more than 6 letters long. If item.length, so the amount of characters in item, is greater than, let's say 6, then we're going to print that item. And now it only prints feather and stolen harp, because potion is exactly 6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times, and n starts at 0 and ends at 7. We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now, I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree, let me go ahead and prove it by using a while loop to fill up a glass halfway. So I'll create a glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet. In which case we will add a certain amount to our glass. We could do a constant amount like this, or in real life when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then when the loop is done, we get to continue down here in our code, and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not climbing the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer her to this going forward. Now, we actually have to be really careful when using while loops, that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line that adds a little bit to our glass every time, well then our glass would actually never become half full and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot, indeed it didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop. So if we were to write if glass is greater than 0.2 and then break, we can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key-value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we are looking up, and the value is the definition. Dictionaries in GDScript work the exact same way. Creating an empty dictionary is really easy. We write var, I'll call this one my dict, and set it equal to some curly brackets. This is an empty dictionary. We can then add key value pairs inside the curly brackets. Say for example that we have multiple players in our game. We can use a dictionary to keep track of them. Each player has a username, this will be the key, and a level, this will be the value. So I'll create a player called Crook, and his level is going to be 1. I'll create another player, Villain, with a level of 35. And finally, a player with the username Boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a comma to the last entry so you're ready for a new one. And let's name this dictionary Players. Then, to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write Players, type in Villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999. And just like with erase, we can loop over a dictionary with a for loop. When we do this, we are actually looping over all the keys in our dictionary, so all the usernames. And for each username in Players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our player's dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary. Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1. And another key called health with a value of 80. And at this point, it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values.
Cara, deixa eu ver. Essa parte aqui eu vou precisar de um dia só pra ela. Coordenação objeto eu não vou conseguir fazer agora não. History é o que? É o the beginning, create node, attach script. Uau! O negócio que eu tava pensando aqui. Talvez foda, né? Se foda.
And now we can access a value by using two keys. Let's print the health of our boss. So print players. We go into our boss and we access the health. And this prints 500, which is correct. So this way we can start to think of ways we can structure data about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game.
Guys,
Say we
chega. Porque vai explodir. Eu tô dormindo. Cara, eu planejei tanta coisa pra hoje. Eu planejei tanta coisa pra hoje mesmo. Mas tanta. A internet conseguiu decepcionar a gente. Mas é isso, guys. Eu vou ficando por aqui. tô curtindo bastante isso. Achei que ia ser muito mais... Eu não sei porque eu achei que ia ser muito mais complicado, cara. Não é nada do que eu já estudei. Nada diferente, né, do que eu já estudei. Mas isso tá ficando muito legal. Muito legal mesmo. Porra, é essa? Bom, é isso, guys. Amanhã eu não vou conseguir fazer. Provavelmente no domingo a gente faça uma sessão muito grande. E é isso. Não tem muito o que falar, não. É isso. Tamo junto. Até mais. Tô muito cansado. Mas também é perceptível, né? Pô, é quase meia-noite. Falou. Boa noite pra vocês.